All right, guys, we are moving on to 4.6b, solving quadratics by completing the square. So by the end of this, hopefully you can say this mission statement: I can solve quadratic equations by completing the square. So first, let's talk about some previous knowledge that we've had, and everything that we've done so far has really been playing into this. Okay, so I want to help you as best I can. Let me turn my volume down here real quick so we don't have people dinging in on us. But let's just talk about a few things here and look at a few things. First, let's just look at this particular quadratic. We had x squared plus 6x plus 9. Now, this is a very special quadratic. If you remember, we'll go through this really quickly. This is factorable. Again, I have a 1 right here. And so that tells me I need to look at this 9, and I'm going to look at the factors of 9. That would add up to a positive 6. And so I can see pretty quickly that these two factors right here add up to 6. So I could factor this out as x plus 3 and x plus 3, which again I could rewrite this as x plus 3 squared. So this is a perfect, that was not perfect the way I wrote that, perfect square trinomial. And again, if we look at the way this kind of factors out, what I want you to notice is this 3 that's right here is basically half of this b term. And I'm going to go ahead and put the standard form of a quadratic up here again for us. I'm having trouble with this pen today, but that right there is an A. Let me do that over because that was awful. Ax squared plus bx plus c equals 0. And so this number here that we end up with is basically half of whatever b is. And then I want you to notice as well that if I take half of 6, which is 3, and I square that, I get this number over here. Okay, so that's pretty important. I want you to try to remember that. But this is basically just a perfect square trinomial that ends up becoming something like x plus 3 squared. Now that's important because we just solved some problems using square roots. For example, if I had x plus 3 squared equals 25, for example, if I can get it to this point, then I know that I could go ahead and take the square root of both sides, and I would get x plus 3 equals plus or minus 5, and then I can go ahead and finish and solve this, right? So if I can get it to this point, then I can go ahead and use this strategy to help me get a solution. So let's take another one that we could factor. Let's take, for example, x squared plus 6x plus, I'm sorry, let me make that minus 7, okay? So if you think about this, again, this does have a 1 right here. You will note as well that I have a 7 right here. So I'm going to think about the factors of 7, which is pretty easy. That's just 1 and 7. But here I have a subtraction symbol, which means that I need to subtract 2 of these numbers to get a positive 6. Well, if I took 7 minus 1, then that would in fact give me what I need. So I could factor this as x plus 7 and x minus 1, and it is factorable. Well, what happens when I get something like this, which is x squared plus 6x plus 7? Now I've still got a 1 here, and I can think about the factors of 7 as being 1 and 7. But the issue is now I have to add 2 numbers to get 6. Well, we know that I cannot add 7 and 1. 7 and 1 would be 8. That's not going to give me 6. So all of a sudden now we have something here that is not factorable. If only, now look at how similar this is to this. Okay, look here at what we have. If only this 7 right here was a 9, then all of a sudden it would look like this, and it's something that I could then solve. Okay, if this was something that I was trying to solve and get a solution for, and all of a sudden I've got issues because this is not factorable. But now I'm going to show you a method that will help you to be able to do this, and it is called completing the square. Okay, So watch this. Here's the original problem we had. X squared plus 6x plus 7. And let's say again, we're setting that equal to 0. This here is my problem child. This is what is really giving me issues. If only I could get that to be a positive 9 right there. Well, watch what we can do here. I'm going to go ahead and leave my x squared plus 6x here, but I'm going to leave a blank space right here. Okay, I'm just going to leave it blank, and I'm going to go ahead and subtract 7 from both sides, and I'm going to get this thing over here to the other side. Okay, so now I've got a negative 7 over here because I moved it. But now, now what do I need to add here to make this become a perfect square trinomial in this blank space that I left? Well, we've already kind of decided I need a positive 9 down there. So watch this. I'm going to go ahead and add positive 9 to this side. But wait a minute. I just messed my equation up because I did something to the left side. But how can I fix that? Well, if I also add this to the right side, then I'm okay, because again, all I've did is I've added a 9 to this side of the equation, but as long as I add it to the other side of the equation, then my equation's still balanced, right? But what really happened here is now all of a sudden I created a perfect square trinomial that now I can go ahead and write out as x plus 3 squared equals negative 7 plus 9, which is equal to 2, okay? So now from this point, I could go ahead and solve this particular problem out, okay? So what I want you to see here is this process is called completing the square. Basically, you're figuring out what number that needs to go right here so that you can make this a perfect square trinomial, and you have a better possibility of actually solving this problem in being able to come up with a solution. So the three things that you're going to be asked to do, there's actually two different things you're going to be asked to do, but I'm going to do three example problems. One of the first things that you're going to be asked to do, and I'm going to call this number 1, is you're given x squared plus 8x plus c. And what they're really asking you to do is to figure out what value needs to go right here, what number needs to go right here that will make this a perfect square trinomial. Okay? So you'll remember when we looked up before, just a little bit ago, that we said that we would take this b term, whatever it is, take half of it or divide it by 2, and then square it, and it will give us this. So let's think about this as kind of a formula. If I take b and I divide it by 2, and then I square it, it gives me this term right here, okay? So now let's go back down and let's look at the problem we've been given. We've got x squared plus 8x plus c. What value do I need to put right here to make this a perfect square trinomial? So here's all you have to do is take b divided by 2 and square it, okay? So again, here's our standard form of a quadratic, ax squared plus bx plus c. My b term is 8, so I'm going to take 8 divided by 2, and I'm going to square that. Well, 8 divided by 2 is 4, and 4 squared equals 16. So a 16 needs to go right here. X squared plus 8x plus 16. Now let's see if that actually worked, okay? So again, if I were to try to factor that, I would have x times x will give me x squared. Look at the factors of 16. That will add up to 8. Well, 1 plus 16 don't add up to 8. 2 plus 8 definitely does not add up to 8. But 4 plus 4 does, in fact, add up to 8. And so look at that. We created a perfect square trinomial. Okay, so in a couple of these questions, that's all you're going to be asked to do is just figure out what this c term right here needs to be. And in order to do that, you just do this process right here. Take b divided by 2 and then square it, and it will give you this answer. So as a matter of fact, for this particular question, this would be your answer right here. It's all you need is just they're asking for c. They're wanting to make sure that you know how to create a perfect square trinomial. All right, so let's move on to number 2 and number 3. So for number 2, we're actually going to practice this here. We've got x squared plus 20x plus 19 equals 0, okay? And initially, by thinking about this, you may think, well, I may be able to factor that, maybe not, but we're going to practice this perfect square trinomial thing just to try it out. So the first thing I need to do is I need to get rid of this 19 right here. I need to get it out of the way, okay? So what I'm going to do, I'm going to go ahead and write x squared plus 20x, and I'm going to leave a blank space, okay? I'm going to move my 19 to the other side. So here's my problem I end up with. Now I have to figure out what needs to go here as a perfect square trinomial. So again, I do the same process again. B divided by 2 squared. So this is my B term right here, right? If I take half of that, 20 divided by 2, all right, is going to equal 10. And 10 squared is going to equal 100. So that means that I need to add 100 to right here, which means I also need to add 100 to right here. Okay, let's think about what happens here now. I have created a perfect square trinomial. So we know that this is going to end up looking like this right here, this x plus 4 squared. It's going to look like something like that, but let's figure out what actually needs to go there. So I'm going to go ahead, matter of fact, and just go ahead and do that. Make me 2 sets of parentheses and put squared. I know it's going to be x, but what was half of positive 20? Half of positive 20 was positive 10. Guess what? That's exactly what needs to go in there. And again, you could work this out to make sure it works out, but x plus 10 times x plus 10 is going to give us this trinomial right here, okay? Now over here, I have negative 19 plus 100, which equals 81. And again, to finish solving this, I could go ahead and take the square root of this side, which would give me x plus 10 on this side. This goes right back to us solving by square roots that we did a couple of days ago. Square root of 81 would be plus or minus 9. In order to finish solving this, I would subtract 10 from both sides. And so I end up with x equals negative 10 plus or minus 9. And again, this is not my answer. I can take this a step further, okay, and go ahead and do the calculations. So negative 10 plus 9 is going to equal negative 1. Negative 10, sorry, I hit my mouse pad. Negative 10 minus 9 is going to equal negative 19. And so my two answers would be negative 1 and negative 19. And just to prove out that that's correct, watch what we can do. We can also go to Desmos, and you can see I've already graphed this particular one here. And you notice what my two zeros are that it gives me for answers is negative 19 and negative 1. And you may be thinking to yourself, well, why in the world wouldn't I just go ahead and do that? Well, the issue is you're going to get some of these that are not going to be whole numbers, okay, which is what brings me to number 3. And this is why we spent so much time actually over the last couple of days talking about simplifying radicals, okay? So now let's go to number 3, which is going to be the doozy, but we can do this. So we have x squared plus 12x plus 9 equals 0. And again, I might originally think of this and think, well, maybe I could factor this. Well, let's look at the factors of 9. Factors of 9 is 1 and 9 and 3 and 3. Well, I can't. I've got to add 2 of these numbers over here to make 12. Well, none of these numbers over here are going to make 12, okay? So this is not factorable. It's like that original example that we looked at a little bit ago. So then I have to ask myself, okay, what can I do in order to do this? Well, in this case, we can use this method of completing the square in order to be able to solve this. So let's take a look at this. One of the first things we need to do is we need to get rid of this number here. In order to make a perfect square trinomial, I have to get this guy over here on the other side, okay? So in order to do that, I'm going to go ahead and subtract 9 from both sides. Now remember, when I write out my new problem, I'm going to do x squared plus 12x, but I am going to leave a blank space right there, okay? I still have negative 9 here, but now I'm thinking about, okay, what could I put in here that will make a perfect square trinomial? Again, it goes right back to the same process again. I'm taking b divided by 2, and I'm squaring it. So b is a positive 12 divided by 2 squared. 12 divided by 2 is 6, and 6 squared equals 36. So that means I need to add 36 right here. If I add 36 to this side, I also have to add 36 to the other side. Okay? So now let's think about what happens here. This is, the whole reason I did this was to make a perfect square trinomial, right? It's just so I can try to help solve this through square roots. So this is going to become x. Remember, what was half of 12? Half of 12 was 6. So it's just x plus 6 squared. That's the whole reason I made this perfect square trinomial, is so I can get to this answer right here. All right, this equals negative 9 plus 36. Negative 9 plus 36 equals 27. Okay? So remember, at this point, my goal has always been that I'm trying to isolate x. So in order to isolate x, I'm going to have to take the square root of both sides, which is going to leave me with x plus 6 equals the square root of 27. But it's not just the square root of 27. Remember, there's a plus or minus that is there. Okay? So square root plus or minus the square root of 27. Now I need to subtract 6 from both sides. And I'm going to move actually, I'm not going to move my work up. I'm going to move my page up. Get rid of that. Okay? So that leaves me with x equals, and you can just write it this way, negative 6 plus or minus the square root of 27. And you might think to yourself, well, Mr. Hamilton, I am done. Finally, I have got to the right answer. Well, the issue is this is not in simplest form right here. There is actually a perfect square hiding in there, okay? So again, if I think about my perfect squares list that I've probably already made by now, then I would understand that this can actually be further simplified. Okay, so this square root of 27 actually has a perfect square of 9 hiding inside of it. 9 times 3 is 27. So the square root of 9 would be, let's finish it, would be 3, and the other 3 has to stay inside. So this, in fact, would be my final answer right here. X equals negative 6 plus or minus 3 radical 3. So you can see why we did that work on simplifying square roots, and why we spent a couple of days on that is because you're going to need that now. Not only now, but you're going to need it later when we talk about solving equations using the quadratic formula. We're going to have to do this same thing here as well, okay? So hopefully this has been helpful. If you need any help, obviously reach out to us, and we'd be glad to try to help you with this process.